We all know resiliency matters, but we often underestimate how fragile our digital world is. Let me start with a few recent incidents. We all remember the CloudStrike outage. Flights couldn't take off, nurses couldn't access patient medication charts, critical government services went dark. The sheer snowball effect shocked everyone. You would think that after such a global incident, we wouldn't see another similar meltdown anytime soon. Well, you might be wrong. In June 2025, Google had a major outage caused by something as trivial as a null pointer exception in their service control system, and it impacted even more companies than CloudStrike outage. If you look at this graph, you would see the number of affected organizations is almost double. And that wasn't all. On 12th September 2025, Cloudflare accidentally ended up DDoSing its own infrastructure. Their tenant service was hammered endlessly because a piece of React code triggered infinite retries on an API call. One faulty call overwhelmed an entire service, took their dashboard offline, and caused a 3-hour outage. Then, exactly 2 months later, 12th November, Cloudflare had yet another massive outage, and this time the impact was so severe that the company lost 2.83% of its stock value in a single day. And one more example, a bit older but unforgettable. A Tesla API outage that locked owners out of their own cars. Imagine not being able to enter your own vehicle during an emergency simply because an API failed. APIs have become a fundamental fabric to our entire digital ecosystem. These examples highlight a painful truth. When an API goes down, everything that sits on top of it comes crashing down. So it is our responsibility to ensure that APIs we build are resilient, predictable, and can withstand a variety of adverse conditions. How do we test the resiliency of an API? There are actually an entire spectrum of tests that we can perform to ensure your APIs are resilient. We could start with something as basic as negative functional testing, where you can do boundary value analysis, invalid data types. You are looking for things like overflow, underflow conditions, and so forth. But that's not enough. Your services rarely work alone. It depends on other services, and those APIs do change. So we need to test what happens when the services don't respond back in time. Check if they are contract compliant, whether the changes made to those services are backward compatible, and if not, how does your service behave? Furthermore, you can expand into a whole class of chaos engineering, fault injection, failover, and other kinds of interesting testing. And then you can turn a notch up by moving into performance testing, where you can do load and stress testing. But my favorite is soak testing, where you leave the system running for a long duration and see if memory, CPU, or any other resources usage goes up gradually. You'd be surprised how many times soak testing shows you that your systems are not really resilient. Of course, we all know about security testing, and they are extremely important when it comes from a resiliency point of view. We just saw a few examples of the kinds of things that can break. Finally, these days, no system can claim that it's resilient without good monitoring, without meaningful alerts, having access to logs, metrics, traces, and ability to detect anomalies early. Without observability, you're flying blind.